everyone, I'm Gonzalez-Barahona, and I'm going to talk about mining software repositories while respecting privacy. This is a part of the educational track of the Mining Software Repositories Conference 2020. The plan for the talk is as follows. First of all, we are going to find out to which extent we should worry about privacy when dealing with data that we collect from software development repositories. Then we are going to explain an analysis of a case, which would be like if we are going to submit a proposal to the European Commission and we want to comply with the data privacy rules that the European Commission is setting. Since the European Commission is one of the more strict funding bodies with respect to privacy nowadays, in the process we are going to find out the different aspects that we need to deal with and why the data that we are using in many cases has a lot of risks from the privacy point of view. Then we will explore some definitions stated in the GDPR, which is the main regulation for this in the European Union. But those definitions are going to be useful anywhere because they are quite similar to other definitions in other regulations. After that, we are going to enter into some details looking at the guidelines that the European Commission itself proposes with respect to how to deal with privacy in data. And we will explore a specific case, which is Git data, which is quite simple because everyone knows how a Git commit is. But we will be exploring the privacy implications of getting that data and sharing that data. I'm not going to enter into these three topics because of lack of time, but you can check the slides if you want. And at the end, there are also some slides with some links to prove further. It's very likely that it's interesting that you download the slides anywhere. You can download there from here. So if you're looking at the video, ensure that you download the slides so that you can click on the different links that you can get in them, because they are going to include much more information and much more details. And a warning or a disclaimer: I'm not a lawyer, I'm just an engineer. I don't have any formal training in law, so please don't consider all of this as legal advice. Before entering into more details, we need to answer the question, should we worry? Should we be concerned about data privacy when we are mining software repositories for research? And of course, we know there is data from persons in the datasets that we work with, at least in most of them. So the question is, how should we be dealing with that data about persons in the context of data privacy ethics and regulations? And to answer the question, of course, we need to have into account both aspects, legal and ethics. From the ethics point of view, of course, we are subject to the recommendations in our field. We need to check them. We also need to check the rules by the bodies funding our projects. And if there is an ethics committee in our institution, of course, we should also be checking with them. With respect to our field, the golden standard for ICT ethics or ethics in ICT research is the Menlo report. Even when it is more oriented towards experiments in which humans are directly involved and knew, at least to some extent, that they were a part of the experiment, still some of the rules or some of the principles are quite applicable to our case. So, for instance, we need to check the different stakeholders' perspectives. We need to know and to try to learn how the data could be used in different scenarios and to which extent we need to protect the data in some of those scenarios. Of course, we also have to respect persons, and especially in this case where usually they were not warned in advance that they were going to be the subject of research. And obviously, we also need to respect the law and respect the public interest. And this is one of the relationships between ethics and law. From this point of view, usually ethics relies on respecting the law. And as we will be saying later, the law may explain in general that you should be following the usual ethics rules. We can also check for more specific concepts related to our research. And of course, within ICT, we are in software engineering. The golden standard for ethics on software engineering, to some extent, is the single invention paper. And there we see similar concepts to the main report, but maybe more focused on what we need to consider. From that point of view, one of the main important aspects of ethics here is informed consent, which as I commented before, is going to be a problem here, because usually the data is collected in advance and for different purposes. So it's very difficult to get informed consent by the subjects. And we need to deal with that somehow. Of course, we have other general principles, but we also have confidentiality. Confidentiality is going to be in clear contrast with the need of publishing the datasets and the intermediate datasets and the results. Because as much as possible, we want to do reproducible science, and that means that all the data involved in our research should be public to some extent. Making that information public, but at the same time, keeping care of the confidentiality of the subjects, of the people involved, is going to be a problem. And more specifically, in the area of mining software repositories, we have a paper in this edition of MSR, which specifically deals with that. It's called Ethical Mining, a case study on MSR mining challenges by Golden and Quink. And you can have a look at it, because it enters into much more details about the ethics of MSR. In any case, in this presentation, I'm not going to focus on all the ethics implications of our research. I'm only going to focus on privacy and data protection. If now we look at it from the law point of view, during the last years, we have had a lot of regulations in different areas of the world. One of them is the European Union, where the GDPR was approved a couple of years ago. The GDPR has implications not only for people staying in the European Union, but worldwide, because one of the statements of the law is that it's applicable to any European Union citizen, which means that if you are dealing with that data even outside the European Union, in principle, you are subject to that law. Of course, in Europe, there is also a specific law in member states, and there are recommendations, which are usually more specific than the law, recommendations by national data protection agencies that we also have to have in mind. And one important thing about the GDPR is that it is becoming influential in other countries, and other countries to some extent are adopting regulations, let's say to some extent in synchrony with GDPR. And in fact, we already have many other jurisdictions where we have, let's say, similar laws or laws that, in some sense, we need to comply with. One well-known case in the States is the California Consumer Privacy Act. But we also have laws in Brazil, Japan, South Korea, and other countries. And in addition to this, international agreements, such as, for instance, the European Union with Japan, usually include some constraints on some regulations on the on data protection. To focus on the kind of analysis that we need to perform, let's consider in a specific case. Let's assume that we are submitting a proposal for being funded by the European Commission. In the process of studying the privacy implications, we are going to check, to review one of the set of requirements related to data privacy, which are more complete now worldwide. So first of all, the European Commission is asking us to be compliant with the GDPR. But that's not enough. As it says, the fact that the research is legally permissible doesn't mean it's ethical. Why? Because in this case, the European Commission is asking us for broader ethical standards than those mandated by the GDPR. So in short, first of all, we need to comply with GDPR. And second, we need to go beyond that, and we need to know the other ethical requirements that the European Commission is proposing, and we need to comply with them too. When doing the analysis, we have to consider at least two specific aspects. One is how the data is processed, and the other one is how the data is published. With respect to processing, we need the data to be lawful, which basically means we need to have a reason for doing it, and that reason needs to be in compliance with the law. And second, the processing needs to be fair and transparent. Let's see what all of this means. With respect to being lawful, basically amounts to having or a specific explicit consent by the data subjects, or being a task in the public interest, or having legitimate interest for doing the research. Explicit consent is quite difficult in our case because that means getting consent from all the data subjects. And remember that data subjects were interacting with the software development repositories in advance to our research, and they were not aware that we were going to be doing any kind of research on their data. So getting explicit consent in this case means usually identifying all the people, all the persons in our dataset, contacting them, and getting that explicit consent. This ranges from difficult to impossible depending on the size of the dataset, how long it was, for how long it has been collected, and so on. So that means that usually we need to comply with one of these other two reasons for being lawful. The first one is quite usual in public institutions. We are doing research, and we are doing research in a public institution, which usually has the public interest as the main aim of the institution itself. So usually we can just be covered by our research is in the public interest. But even if we are in a non-public institution, we still can say we have a legitimate interest for doing this, which basically means we are entitled to do this because we have an interest which is not in conflict with the rights of the data subjects. With respect to fair and transparent, we need to clearly state the safeguards that are going to be used for protecting the data and the data processing itself. And usually that amounts to ensuring everything needed, both from the technical point of view and the organizational point of view, so both technical and organizational, to protect the data related to privacy of persons. That means having a specific ways of accessing the data, having a specific ways of dealing with the data, having a specific ways of removing the data once it is not needed, ensuring that we are going to use only the data that we need and nothing else, and ensuring that only the people that needs access to the data is going to have access to it. So this is not easy, but basically we can define a procedure for all of this, stating how the organization deals with the data and which technical means are prepared for dealing with the data. All of this with data processing. With respect to data publication, the main point that we have is at the end of the research, we usually want to publish the data because we want the science that we are doing to be reproducible science. We need other groups to be able of checking what we did, and for that we need to share the data with them. But sharing the data, according to these rules, should be done through a managed process with controls of access and usage and protecting data from re-identification. All of this is contrary to the idea of open science and open data and publishing all the data sets that we have. Because in that case, there is no managed process, so we are just publishing the data. There is no control to access and usage, we are just publishing the data. And the protection from re-identification is dependent on the kind of research we are doing. In some cases, identifying the people is important to the research itself. So this is clearly a potential problem for the publication of results. And this is quite interesting because in the specific case of the European Commission, they are also promoting open science. So you need to find the balance between publishing open data and having the research being open science with respecting privacy from individuals. And the answer usually comes from anonymization. So there are specific provisions for how, if the data is anonymized, you can share it. But even in that case, even if you create using only anonymized data, you still need to deal with how the data was occurred, how the data came to you. And you need to be sure that the source of the data is ethical from the point of view of these recommendations. There are also some comments on the pseudo-anonymization. Pseudo-anonymization is basically the kind of anonymization that we do, the kind of transformation of the information that we do that makes it difficult to de-anonymize people, to find out who the individuals are, but still keeping enough information for the research to be done. This is tricky, and later on I will be talking about the specific examples of how pseudo-anonymization maybe is not working as it should, at least in some cases. Well, with all of this in mind, the European Commission has a specific table with all the things that they consider or that they think could lead to higher risks related to GDPR in research. So it's worth checking our research with all of them, because in that case we can see where we are in, let's say, more trouble territory. So what do you think? Stop the video now and have a look at this list and try to find out which ones of these are specific risks that we are dealing with when we are researching on data mined from software repositories. Okay, did you check which of these risks could be associated with our research on mining software repositories? Let's look at my analysis. So all of this could be related. Those in yellow are all depend on the dataset. Those in red are very usually we are dealing with that. So you can see of the first category, well, we don't really deal with personal data related to racial origin, to political opinions, so trade union membership. So that's very rare. So we can forget about that. But for the other categories, we are either in red or in yellow most of the time. So let's analyze all of them very quickly. So starting with data subjects. Well, very likely we have children and vulnerable people in our data sets. Maybe we don't know, but they are still there. So since they are subject to special protection, they should be especially protected. Even if we don't know, others could know, and others could drill down in our data sets and identify those people. This is very difficult to deal with, because in most cases, we don't know who they are, so the only chance that we have is dealing with everybody as if they were children or other vulnerable people. As I said, we usually don't have explicit consent, because we collect the data from services, and those services didn't get a specific consent for our cases, for research, or for anything related to our studies. Even if they got that permission, usually they don't guarantee that permission for us. I mean, maybe they collected some consent from their users for their own treatment of the data, but usually that's not extensible for us when we use the same data. So in summary, usually there is no specific consent. Can we avoid this case? We saw how we can avoid it by using the other areas for lawful use that we were discussing some slides ago. So next case, the scale or complexity of data processing. Well, we are dealing with a large scale. Usually we are having several data sources. Usually we think that the more data the better, so we try to have large data sets when possible. And if we can combine data sets, we do. The problem is that the better the research, the riskier. So that we need to be careful, specifically in this area too. And then when we come to data collection or processing techniques, we have in red data mining, because obviously what we do is data mining, but we also have some stuff in yellow. So first of all, privacy invasive methods. So in some cases we are doing analysis that even when they are very interesting for research, could be privacy invasive. So one example could be, we can analyze who is working off hours. We can look at people and time patterns for them, and we try to infer who of them are working off hours, who of them are working during the weekends, or after the usual job schedule. For that, we track individuals, and we can tag specific people. We can learn when people are working, when they are getting vacation, when they are getting days off. All of these have potential implications on privacy. We also mine from social media. In fact, most of the repositories we are mining are, to some extent, are social media. So, for instance, GitHub is one social media for developers. Developers talk them with each other. They produce stuff, coordinating together, etc. So, in the end, data mining is what we do for research. And we can also, in many cases, profile individuals or groups. So, for example, we may be interested in the activities by newcomers. The first thing that we do is to identify newcomers and therefore to profile people as newcomers. So, of course, there is a risk of tagging specific people instead of tagging just anonymous people. So, in the end, we can show a specific activity of persons, and we may be profiling them. And of course, we can also use artificial intelligence techniques, machine learning, for instance, to analyze personal data. Common case is try to find out experts in some field. We try to analyze activity using machine learning for trying to know who are experts in some languages by analyzing the code they are producing or whatever. So of course, again, the risk is singling out specific persons with respect to their capabilities in this case. And finally, with respect to the GDPR, there is also the involvement of countries outside the European Union, which means transferring data from and to the European Union. But that's something that we are doing all the time. We are collecting data from non-European Union data sources, even if we are in the European Union, and we are sharing it with researchers worldwide, which means the data is traveling in and out from the borders all the time. Can we avoid these scenarios, really? After analyzing the risks, let's check at some guidelines that the European Commission is also proposing as a part of the documents. They are based on the case that we presented before. We are submitting a proposal to the European Commission, but they are useful everywhere, even if they may not be mandatory. So in any case, what the European Commission proposes is to have a detailed analysis of the ethics issues raised by our research. And that involves, first of all, study data collection and processing operations, so try to study everything that is going to be done with the data. Second, do a specific analysis of all the ethic issues that's going to rise, having a special attention to the high risks or the highly risky activities that were mentioned before. And then, for each of them, propose the mitigation measures that we are going to have in place for those risks. In addition to this, we should be also submitting the analysis to the Research Ethics Committee of our institution and include their input in our analysis as we submit the proposal to the Commission. As I said, this is mandatory for European Commission funded research proposals. And from the, let's say, European point of view, it's important to involve the DPO. But in other countries, probably you have similar actors, similar figures. So basically, the local expert on data protection. And maybe as a result of the research, you need to conduct a formal DPIA, so that data protection impact assessment that we just mentioned. The overall GDPR approach, which is consistent with these guidelines, is what they call data protection by design. That's why it is important to analyze in advance what we are going to do with the data, because the idea is to incorporate data protection to the processing of the data from the very beginning. So that even before we are starting to touch the data, we already know how we are going to protect the privacy of the persons that could be involved. In research, there are several things that we should have into account. So first of all, when we are trying to have data protection by design, we should be anonymizing as much as possible. If we don't need the data to be identifiable, let's make it anonymous as soon as possible in the data collection and processing process. If anonymization is not something that we can do because of the kind of research we are going to do, let's try pseudo-anonymization again as early as possible. Second, let's try to minimize the data that we are going to deal with. In this context, minimizing the data means ensuring that we are going to use only the data that we need. Then, let's use cryptography when needed, mainly for the pseudo-anonymization thing. Let's try to hash when that's feasible. Let's try to encrypt when that's feasible, so that we don't deal with real identities, except when that's specifically needed, which in many cases is not. Let's also focus on our survey providers and estuaries to determine how data is going to be protected. So we should ensure that only the people who needs to access the data is really going to be able of accessing the data. And from the very beginning, we also need to define the procedures for exercising fundamental rights. So what if some person in our data set, for instance, thinks for any reason that their privacy is being violated? So what we are going to do? And also how they are going to have access to us, how we are going to give access to other people, and if needed, how we are going to ask for consent. As I said, data minimization basically means that we are going to use only the data that we really need, only the specific data needed for the purpose. And the idea is to avoid collecting personal data as much as possible. So if our research is not going to use names, for instance, avoid collecting names. If you need to collect names because the API is producing names, try to remove them from your data stream as soon as possible, and so on. Try to anonymize and pseudonymize as soon as possible. Try to store and process the data securely. Especially if you are doing that in the cloud, ensure that only the right people have access to the data. If you are using public infrastructure in your university, for instance, again, ensure that the data is adequately protected. Remove the data, delete the data when you no longer need it, especially intermediate data. And limit the access to the data as much as possible. And as I said before, even if this is in conflict with the idea of open data, try to ensure that if the data is going to be open, that's because privacy was considered in detail, and the data can really be open data. The mitigation measures that you need to design usually are based on anonymization and pseudonymization, as I said. But even in those cases, you still have to deal with ethic issues, like the origin of the data. As I mentioned, you need to be sure that you are getting the data lawfully and ethically. You also need to think of the potential misuse, not only of the results, but also of the methodology or of the findings of your results. And of course, if the data could be de-anonymized and which effects that could have. Now, let's check a practical case. Let's assume that we are collecting commits from a lot of repositories for an analysis involving computing commuters over time, commuters per time period. We want to publish the dataset as a part of our reproduction package in a way that commuters per time period can still be computed by third parties. First of all, let's assume we have some lawful basis for the data processing itself. Let's assume that we are doing in the public interest, for instance. And the steps in this case are going to be, let's identify which information about individuals we have in our data. Let's study if we can remove it. And if we cannot remove it, let's study how to pseudo-anonymize it. Let's go. So this is the can of data that we have in a commit record. And we can easily spot the name and the address, which is going to be the data that we need to deal with carefully. In addition to the author field, we also have the commuter field, but it's basically subject to the same issues, so we are not going to include it. We have the hash for the commit, we have the date for the commit, and we have the commit command. How to identify the personal data? Well, as I said, probably in this case it is obvious, but Let's check at the definition of personal data. Any information relating to unidentified or identifiable natural person. That includes, for instance, names or online identifiers. Email address, for instance, is an online identifier. And to be clear, personal data includes a lot of things. For instance, it also includes IP addresses, because there are unique identifiers that could lead to identifying people. So in any case, it is clear that names and email identifiers are potential issues in our dataset. So let's go and try to remove them from the dataset. But if we just remove them, we can no longer compute commits per month, for example, committers per month, for example, because we need to classify commits by author. If we miss the author, we cannot classify them by author. So we need to keep the data, but anonymizing it in somehow. So that's pseudo-anonymizing. In any case, it's important to realize that the data is public in the first time, because we are dealing with data from public repositories. Let's assume in this case the data comes from a public GitHub repository. So we could think, well, there is nothing to do, because the data we are trying to pseudo-anonymize is public in the first place, so we really don't need to do that. That's not the case. The rules for open source case are clear, for open source data are clear. So how to use open source data? The fact that some data is publicly available does not mean that there are no limits to the use. So basically, the limits are the same. You must ensure the data processing is fair to the data subject and fundamental rights are respected. So in short, we still need to de-anonymize the thing. Let's go on. There's more detail on data obtained from social media networks and so on, which basically goes in the same line, so I'm not going to enter into the details here. So how can we fix the problem? As I said, if we anonymize, we are going to strip all personal data, and that's not good enough because we cannot reproduce the research with that. So the only chance is pseudo-anonymize the data. In this case, it's going to be much more interesting for researchers, but there are some issues. Let's go for them. So first of all, what's pseudo-anonymization? Well, it's processing the data so that it cannot, the original identifier, the original person cannot be identified from the results of pseudo-anonymizing. In other words, we are going to try to maintain as much information as possible, but not enough information for reverting the process and getting the original identities. Okay, so this is just some more definitions of pseudonymization and the difference with anonymization and the re-identification process. Let's look at them in detail, but let's go to the meat. How can we do that? So the first thing that we can do is to just compute hashes. In this case, we are converting this identity, the identity corresponding to this email address, to this hash, just by hashing it. In this case, with this tool available in Linux, for instance. This is going to produce a common hash, and basically we are going to substitute the author field for the hash of the address. The rest of the commit record, which is all of this, is pretty much the same. But this is not good enough. Have a look at this blog post if you are interested on how you can de-anonymize email addresses easily. And the key is that hashing is a process designed to be quick, which means that you can de-anonymize a really huge amount of email addresses with a little processing power. So in this case, you can see how just using MS on EC2, you can de-anonymize 450 billion hashes per second, which, having into account that in 2019 it was estimated that there is like 5 billion email addresses, well, it's not a big deal to really do the de-anonymization very quickly. Of course, this depends on you having the addresses to de-anonymize, but that's also not difficult because there are lists of email lists for sale, there are data breaches leaking billions of addresses, and in the specific case that we are considering, you could just target email addresses in Git commits in GitHub, which is maybe like 50 million addresses. So if somehow you can get them, you could de-anonymize any dataset, anonymize it this way. So let's go for something more specific. We can hash name plus address. This is slightly better, but if you have the name in addition to the address, you can also de-anonymize the same way, just by hashing collections of names plus addresses, which is in the end is what you are going to have if you are harvesting email addresses, for instance, because usually in email messages you have both the name and the address. More interesting choices or alternatives are salting the hash, using a different algorithm, using non-hash functions like, for instance, codes, or encrypt instead of hashing. Encrypt in the end means more computing power, which means it's more difficult to break. Salting the hash is going to make it more difficult because you need to check not only a single name and address combination, but all the combinations of name, address, and salt. And using non-hash functions means that if you don't have the code, you cannot recover the original identifier. So it is better than the just hashing. But if you want others to merge with your dataset, you need to disclose the details. You need to disclose how you did that, so that if another researcher using a different dataset wants to merge with your dataset, can identify the same people with the same identifier. So that you need to somehow inform other researchers wanting to merge with your dataset of how you pseudo-anonymized your data. So we can see how a possibility is emerging. We could use either encryption or coding, and we could make the datasets public, but the key or the coding table, which are necessary for de-anonymizing the data, that would be given only to researchers asking for it, so that somehow we would try to assert legitimate use by only giving the data to trusted parties. For instance, researchers signing a contract, or basically you tell them what they can do and they cannot do with the data, and you are confident that they are going to comply. Of course, a variance of this is to reference the data in the paper, but in that case, the data becomes public, which is probably not a good idea from this point of view. But remember that we are all the time trying to balance between making as much data public as possible and making it difficult to de-anonymize the data. But the problem is that even in this case, where we are going to have the author anonymized in a way that only if you have the code for de-anonymizing, you can recover the original idea, the original identifier. And that code is basically this table where you have all the identities linked to the corresponding code, and only those persons with the table can do this de-anonymization. Still, you are subject to this kind of attack, which is using the commit hash, searching it, for instance, in GitHub, and then you get the commit record and the identity of the person authoring the commit. Of course, this can be automated, so that you can just guard, for instance, to get basically the same information, so that you can do this in the large automatically, very easily. So if you have the data set, you only need to check all the hashes to get the identities. And by the way, once you get the identity for a hash, you don't need to check it again, because the identity is going to be the same. So we still have a problem. And what can we do? Well, we can pseudonymize the hash, so that instead of having the real hashes, we pseudonymize the hash with another code. And now the commit record becomes this one. The author is pseudonymized, the commit is pseudonymized too. And you could think, is this good enough? Think about it. Well, it's not. You can still go to GitHub and search for the commit record. And again, find the commit very easily and find the identity of the person. Of course, this depends on how common is the commit record, the commit comment. But you can just check for commit comments which are uncommon for any identity you may want to de-anonymize. So we still need to pseudonymize the command and the date to avoid similar attacks based on the date, and have separate coding tables for all of this, so that only the persons with the coding table can de-anonymize the data. But now, de-anonymizing includes the commit hash or the date, which means, for instance, you can no longer compute committers per month using only this data. You need the coding table for being able of converting the date to a given month. So in this balance, we were able of anonymizing almost everything, but if we don't have the separate coding tables, the data is becoming less and less useful, which is, of course, a problem. So remember why we need the tables. We need the tables because in some cases we need different levels of de-anonymization. So, for instance, for reproduction, we have seen how even for this simple study, even if you just want to compute commits per time period, you need to map dates to time periods, to months, for instance. And for that, the code is not good enough. You need the actual date. For reuse, you also need to merge identities. If you are going to merge this with another data set, for instance, or if you want to find out the relationship between messages and time of day, or if you want to link commits to issues. So for all of this, very likely the pseudonymized commit record that we had in this slide, this one, is not good enough. So that's why for most of the staff, we actually need the coding table. So basically, we need to share the coding table with anyone using the data, or almost anyone using the data, which puts at the start again. So in that case, it doesn't make a lot of sense to consider the data as open data, because for using the data, you need the coding table, which is no longer open because of privacy concerns. This is a general problem for anyone when the data is public. If you have public data, there are many ways of de-anonymizing it, in addition to just using the algorithms that you can use to reverse the pseudonymization.